All right, today's aim is let's draw line segments connecting midpoints of the sides of triangles. All right, so I'd like you to answer 5.1 on Google Classroom. Just write what you notice, what you wonder, and I'd like you to write at least two things you notice and two things you wonder, all right, on Google Classroom. All right, so let's jump over to 5.2. All right, so please do that notice and wonder first before watching 5.2. Okay, here's a triangle ABC. Points M and N are the midpoints of the two sides. All right, and I can tell that they are the midpoints because if we see here, AN has 2 hash marks and NC has 2 hash marks. So clearly AC has been cut into 2 equal parts. That's the definition of a midpoint, right? If it's the equal distance on either side. Same thing here, I have 1 hash mark and 1 hash mark. All right, so convince yourself triangle ABC is a dilation of triangle AMN. What is the center of dilation? What is the scale factor? Well, one of the biggest things we talk about when we talk about dilations is that the image and pre-image are similar triangles. They're the same shape, all right? So that means that my angles are the same and I've got a scale factor between my corresponding sides. So right now, I'm gonna try and show that these two triangles in the diagram are in fact similar. So we notice that they both share this angle CAB or NAM. All right, so we can say that this angle is congruent in both triangles by the reflexive property. All right, and I'll draw this on the side here just to really drive home that point. If I draw that big triangle here, ACB, all right, I've got that same angle right here. And then I also know that this entire side is the combination of those 2 hash marks. And then this whole side is the combination of those. So we can say by side angle side similarity that triangle ACB is similar to triangle, let's see, ACB, so that'd be ANM. And that's by side angle side similarity. All right, so that just lets us know that we've definitely got a dilation here because I know that the two triangles are similar. All right, what is the center of dilation? Well, both triangles have A in common, and I can see that my lines of projection are starting at A and going through N, and then also starting from A and going through M. So my center is point A. All right, what's my scale factor? Well, if I've taken this line segment and then copied it into the identical line segment, I've essentially doubled it. So that scale factor would be 2. All right, convince your partner that triangle ABC is a dilation of triangle AMN with the center and scale factor you found. This would have been nice to have done in class, but of course, since we are in the situation we are, we can't really do number 2 right now. All right, with your partner, check the definition of dilation on your reference chart and make sure both you could convince a skeptic that ABC definitely fits the definition of dilation. Well, dilation really means that we've taken a shape and we've created a similar shape. All right, so we've proved that the two triangles are similar. So that's enough to show that we've definitely got a dilation. We know that A is collinear with N and C, collinear with M and B. So that we've got our projection lines of dilation here. And I've got the same scale factor. I've doubled this side to get the whole side, and I've doubled this side here to get the whole side there. All right, convince your partner that segment BC is twice as long as segment MN. All right, and this is pretty similar to what question 5 is asking. Prove that BC equals double what MN is. But I'm gonna try and do this with a proof, and that should be enough to convince a partner that it is twice as long. Okay, so if we're looking at BC and MN, right, we can tell by looking at our similarity statement, BC and MN, those are corresponding sides. All right, so to really show that we've got a scale factor of 2 here, I'm just gonna label this side X and this side x as well. All right, I know those aren't the two sides we're trying to prove right now, but it'll be helpful to show these two sides have that same scale factor. All right, so if I look at the entire side AC, I've got x plus x, which is really the same as 2x. All right, so if I want to make a proportion, right? If I want to make a proportion, let's say we've got AC over AN, right? AC is the long side, AN is the short side, so I know they correspond, right? AC and AN are corresponding here. And I replace them with the variables I've used. So AN is x, and then AC would be 2x, right? And I simplify that, cancel my x's out, I'm just left with 2. So that's a great way of showing that we really have a scale factor of 2 here. So using that, let's call MN y, and using my scale factor of 2, I'm going to double y, and I'm going to get 2y up here. So we can say that NM, or they used MN in the problem, so I'll use the same order just to make it easier. MN equals y, and BC is equal to 2y. Okay, so if I know MN is equal to y, I can substitute MN for y right here. So I get BC equals 2 times MN. All right, and that's exactly what we wanted to prove right there.